Hello and welcome to section 12.1, which is on tangent lines. So the tangent to a circle is a line in the plane of the circle that intersects the circle in exactly one point. Point of tangency is the point where a circle and the tangent intersect. Theorem 12.1 is the one that we're going to use to do this first example, and it says that if a line is tangent to a circle, then the line is perpendicular to the radius at the point of concurrency. A lot of big words there, right? Here's my picture of a circle. It says that ED, which is this one right here, this top line, is tangent to the circle, okay? It intersects the circle at exactly one point, right here. That theorem says that if that line is tangent, then it is perpendicular to the radius at that point. So therefore, you can draw your little right triangle here. And I've already showed you that 38 is right here. And because the theorem says that it is perpendicular, we know that's a right angle right there. So then I should be able to find my x, which is this one. So I have 90 plus the 38, which is 128. And then I just need to remember that triangles have 180 degrees in them. And I subtract 128 from 180. 52 degrees is your x in that example. Theorem 12.2 says that if a line in the plane of a circle is perpendicular to a radius at its endpoint on the circle, then the line is tangent to the circle. So very similar to what that last one just said. Okay, so here I have my example drawn for this theorem 12.2. So if a line in the plane of a circle is perpendicular, so this one right here, if it is perpendicular to a radius at its endpoint of the circle, then the line is tangent. So they're saying this line right here is tangent because it is perpendicular to the radius at its endpoint on the circle. And because it is a right angle right here, it is a right triangle. And because it's a right triangle, we can use the Pythagorean theorem to solve this. So in this case, remember that C, which is the hypotenuse, is always over here. It is across from the right angle. I know that then I have a squared plus b squared equals c squared. Your a, it doesn't matter which side you use. I'm going to go ahead and use this side, but it doesn't matter. I could use the other side also. That leaves this side to be b. So x squared plus 10 squared equals my c squared, which in this case is x plus 6 squared, because it is this whole side. And because I have it in two pieces, I have to go ahead and square that. So I have x squared plus 10 squared equals, and I have to go ahead and take x plus 6 times x plus 6. So FOIL method, x squared, 6x and 6x, so I have 12x, and then 6 times 6 is 36. And then I just need to go ahead and finish this. I need to get everything on one side here. So I could go ahead and say that 10 squared is 100, because I can tell that by looking at it. So I can minus my x squared, move it over here. It's gone now. Minus 100 from over here. So what you have left then is 12x equals negative 64. Actually, that should be a plus. So then, to solve that, I need to move. Right now, I don't have anything over here. I've moved everything. Because this 64 is negative, I'm going to move it over there. So I'm going to go plus 64. And I'm running out of room here. So I'll put it over here. So 64 equals 12x. Go ahead and divide by 12 for your last step. That makes x, which is your radius, equal to 5 and 4/12, so 5 1/3. And I don't have a label, so it would just be units in this case. So there you can use the Pythagorean theorem and your knowledge of tangents to solve that question. Another example, and I need to draw the diagram here. So here's my diagram to go with this. It says if NL equals 4, ML equals 7, and N all the way over to M is 8. They want to know, is ML tangent? The way that I'm going to be able to figure this out is, does the Pythagorean theorem work? It has to be a right angle for this to work, right? This right here would have to be a right angle, but it's not saying that for sure. You have to figure out if those numbers will make it work. So a squared plus b squared equals c squared, Pythagorean theorem again. And you know that the a and the b have to make up the right angle, which would have to be right there because the tangent has to be perpendicular right there. So you would go 4 squared plus 7 squared equals 8 squared. 16 plus 49 does not equal 64. Right? It's 65 actually. So it does not equal 64. So the answer to the question is no, that is not a tangent, because it would have to be, the Pythagorean theorem would have to work for that to be perpendicular right here. So no, it is not a tangent. The last theorem that we're going to cover today is theorem 12.3, which states that if two tangent segments to a circle share a common endpoint outside of the circle, then the two segments are congruent. And I have an example here. Let me draw the picture. So here's my example. And I realize I ran out of room there on the left, but you get the point here. The triangle, the circle is inscribed inside triangle PQR. The whole way around this thing has a perimeter of 88. And then it says what is the length of, there should be a Z right here. What is the length of Q to Y? Okay. So if you go back up here and look at what this theorem said, if two tangent segments to a circle share a common endpoint outside the circle, okay, so QR right here is tangent to the circle, and so is PR, and they share this common endpoint, as do QR and PQ. They share this, and then PR and PQ share the one that's off the screen here a little bit. So then we know that the two segments have to be congruent, okay? So they gave us that this one up here is 15. If you use that theorem, you also know that this is 15. They gave us that this one is 17. We also know that the other half over there is also 17. So if you add those two things up, the top is 30, the left side there is 34. That is 64. They're telling you that the perimeter of the whole thing is 88. So you subtract those two numbers, and that should be 24. But it's 24 for the whole side. So if you take 24 and you divide it by 2, you get 12. And let's just say, better label it. So 12 centimeters equals Q to Y, and then Y to R would also be 12. And therefore the perimeter walking all the way around the outside of that would equal the 88 centimeters that they are talking about. So bring that knowledge with you about tangents and circles, and we will talk about it more the next time I see you. Have a good night.